Hello friends and welcome again to a one notch higher discussion of questions. Right now I am going to present before you something not so direct as it was in the previous slide. Well, last time we discussed IIT main pattern questions and this time we have IIT advanced pattern questions. So let's see what is the very first one. The first question says, two finite sets have m and n elements respectively. That means the first set which you are going to consider is going to have m elements and the second set has n elements. Both m and n are natural numbers and therefore both the sets in picture are finite sets given, whereas m and n are their very cardinalities. The total number of subsets of the first set is 112 more than the total number of subsets of the second set. In the entire line there is one concept being stressed, which is total number of subsets of a set. The value of m and n is being asked now. So let us proceed with this question. I am given two sets. The name of the sets is not specified. Let us just take A and B as the two sets. Suppose I take A and B be any two sets such that the cardinality of A, that means number of members sitting inside the set A, is m, and the cardinality of the set B, which is number of members sitting inside set B, is n. Now, as I stressed on the fact, total number of subsets of both the sets is coming into question. Do we know something related to the total number of subsets of a finite set? Yes, we do know. What is that result? The result is, if A is any finite set with n elements, then the total number of subsets of A is equal to 2 to the power n. What is this n? This n is the cardinality of the set A, and therefore this comes out to be 2 to the power cardinality of A. This is the very result which we have to bring in question right here. And therefore, because cardinality of A is given to be m, therefore total number of subsets of the set A is equal to 2 to the power cardinality of A, which is m, and total number of subsets of the set B is similarly 2 to the power cardinality of B. What is cardinality of B? It is equal to small n. Once we have obtained the total number of subsets of A and of B, let's see what the question says. The question says that the total number of subsets of the first set, which is A, is 112 more than the total number of subsets of the second set, which is set B. That means it is saying that the total number of subsets of set A, which is 2 to the power m, is equal to actually not equal to 2 to the power n, which is the total number of subsets of set B, but once you add 112 in the number of subsets of B, you are going to obtain the number of subsets of A. Therefore, what is given is that 2 to the power m, which is total number of subsets of set A, is equal to total number of subsets of set B with 112 added. Is that understood? And therefore, what am I going to do is the obvious calculations. Just bring 2 to the power n to the left hand side. Now my task is to bring 2 to the power n out common. What you are left with is 2 to the power m upon 2 to the power n minus 1 is equal to 112. We all know how is 112 factorized. If I try to factorize it right here, we know 2, 5, 6, then again you can factorize it, then again, and in the end you get a 7. And therefore 112 can be written as 1, 2, 3, 4. 4 times 2 multiplied by a single 7. And now we just have to sort this out. This is 2 to the power n. This is 2 to the power m minus n by the very laws of exponents. Minus 1 is 2 to the power 4 into 7. Now if you try and consider the statement that we have got, this particular term gets compared with this particular term and this bracket gets compared with this. And therefore what you obtain is 2 to the power n is equal to 2 to the power 4 and 2 to the power m minus n minus 1 is equal to 7. Only then can this expression occur. Now, if 2 to the power n is equal to 2 to the power 4, my n comes out to be 4. Once I have obtained n, just substitute the value of n in the next expression, which is 2 to the power m minus 4 minus 1 is 7, which means 2 to the power m minus 4 is 8. But you know what 8 is? Just make 8 something of the form 2 to the power. We know 8 is 2 cube. 2 2s are 4 and 4 2s are 8. What you obtain from here is m minus 4 is equal to 3, which means m is 7. This way we have obtained the values of n and m. M is 7, n is 4. The pair that you have to search for is 7, 4 because the question is asking for cardinality of A and then cardinality of B. Therefore, m is 7 and n is 4. Let's see if 7, 4 tuple is sitting over here. This is not 7, 4. This is the wrong answer. 4, 7, I don't want 4, 7. What I want is 7, 4 and that is why option number C is the very correct option. This question is done in a simple format if you just understand the logic of this result and also remember your exponential laws and comparison factors. Now we will proceed on to the next question, but only when you have these in your notes with you. It's now turn to move on to the second question. Just have a look at the second question and try to see if you can come up with some kind of a solution. Once we have the second question, I'm sure you guys must have read it. Let's see what it concerns. The question is saying that you have a survey which is showing that 70% of the Indians like mango and 82% of the Indians like apple. If X% of the Indians like both mango and apple, then find out which equality or inequality fits for X. Therefore, we just have to find the value of X%. Let us try and deal with this question. I don't know how many total Indians we have, but because percentage is being concerned, it is obviously upon 100, and therefore let us assume the total population of Indians is 100. Let the total population of Indians being surveyed is equal to 100. Now, if I try and make my set A to be the set of all those Indians who like mango. A is the set of all those Indians who like mango. Now, what is the number of such Indians? Number of members sitting inside A is actually the number of Indians out of the total who like mango. Here it is given that 70% of the total Indians like mango. That means 70% of 100, because that is what is the total population. And 70% of 100 is nothing but, when you do it, a 70 is what you get. Similarly, if I make the set B to be the set of all Indians who like apple, in that case, what is the number of such apple liking Indians? Number of members inside B is given to you in the question. It says 82% of the total Indians like apple, which means 82% of the total population, which is 100. And what will you get is 82 upon 100 into 100. This is going to deliver 82 to you. After that, they say that X% of the Indians like both mango and apple. That means X% is the number of Indians out of the total Indians who are sitting inside both set A and set B. That means A intersection B is what is referred in the question, and number of members in A intersection B are those Indians who like both mango and apple. And this number is given to be X% of the total population. So this is X% of 100, and by the very similar format, you get this equal to X. This is what you have to find out. Now we turn on to how do we deal with it. Once you have intersection with you, number of members in B with you, number of members in A with you, all these three given conditions trigger us to use one formula, which is number of members in A union B is number of members in A plus number of members in B minus number of members in A intersection B. This is the formula all of us are aware about. From this you get number of members in A union B is equal to number of members in A, which are 70. So you get 70 plus number of members in B is 82. 70 plus 82 minus X, because number of members in A intersection B is your very X. Now what you get is, just bring X this side, you get 70 plus 82 is 152. So you get 152 minus number of members in A union B. The next thing is, What do you think can be the estimate for number of members in A union B? Well, the entire population is given to be 100, among which the survey is being done. This means number of members in the universal set is 100. Now at the max, the A union B set can be equal to the universal set, or in the other case it can be strictly less than the universal set. Therefore, number of members in A union B can be either less than the number of members in the universal set or at the max be equal to the number of members in the universal set, which is 100. Therefore, we know that number of members in A union B can be less than or equal to 100, which is number of members in the universal set. Now, what do you think minus of this will do? Minus of number of members in A union B is going to reverse the inequality sign and give us a minus 100 here. Now 152 minus this, so 152 minus number of members in A union B will be greater than equal to 152 minus 100, which is 52. But what is this that I have obtained? Isn't 152 minus number of members in A union B equal to x? Yes, so you have got that x is greater than equal to 52. This is the very first equation. Now comes the time to understand if x is greater than equal to 52, which means minimum. At the minimum, at least 52 members or 52 Indians are there who like both mango and apple. Now is the time to understand the maximum bound. X is less than equal to what? Therefore, let us use a very small fact. All of us know that A intersection B is a subset of A. That means A intersection B is obtained by borrowing members of A. If you don't believe this, you can watch this with the help of a small Venn diagram. Suppose I take two sets. What is my A intersection B? This is my A intersection B. Very clearly, A intersection B is a part of A. It is a set which is obtained by taking those members from A which are lying in B also. Therefore, A intersection B is not just a subset of A. In fact, A intersection B is a subset of B also, because the same situation is happening with B also. Now, as you can see, even in a very generalized form, number of members in A intersection B will be less than or equal to the number of members in the set A, because A intersection B's size is smaller or at the max equal to set A. When can A intersection B be equal to set A? When there is the numbers in both of them are same. Therefore, at the max a subset can be equal to the parent set, or in the other case it can be strictly smaller than the parent set. Therefore, the number of members which a subset contains will always be less than or equal to the number of members which the parent set contains. Therefore, what I have is that number of members in A intersection B is less than or equal to number of members in set A, and also number of members in A intersection B will be less than equal to number of members in set B, by both these very conditions. What is number of members in set A? Number of members in set A is 70, number of members in set B is 82. So here I am going to write 70 and here I am going to write 82. If something is less than 70 also and the same thing is less than 82 also, what do you think it is definitely less than? Well, let me just draw a small number line. If this is 70 and this is 82 and numbers are less than 70 and less than 82, that means to the left of 70 and to the left of 82, those numbers are definitely less than the minimum of 70 and 82, which is 70. And therefore, from these two, you get number of members in A intersection B, which we know what it is. That is what is your X. And you get that your X is less than equal to 70. This is my second equation. From 1, you get that minimum, at the very minimum, X can be 52. That means X is greater than or equal to 52 and X is less than or equal to 70. Do we have something like this in the options? Let's go and check. Yes, X is greater than or equal to 52 and X is less than or equal to 70 is very much lying here. And therefore, B is my correct option. Note this down with pretty much intricacies there are in this question. So, quickly note this down very carefully. I have already presented before you question number 3. Take a look at it so that we are ready to deal with it. Question number C is giving you certain abstract format of set. What does it say? It says X is an arbitrary set which when taken union with a set with just two elements 3, 4 is giving you this set. The options are which of the following is true? Smallest set X is this, or smallest set X is this, or smallest set X is this, and the greatest set X is this. Let us try and see among the 4 options which one suits us the best. I am given that X union 3, 4 is giving me 1, 2, 3, 4, 5 and 6. Now let us try and look at the options. The first option is if I take X equal to 1, 2, 5 and 6, will this condition still be true? So let firstly my X be equal to the first option, which is 1, 2, 5 and 6. Then X union 3, 4 is 1, 2, 5, 6 union 3, 4. When you take the union of two sets, you just have to collect the distinct members in total and put them down in the union. 1, 2, 5, 6. In fact, 3, 4. All the members in total are distinct. Just put them all inside one set and you obtain 1, 2, 5, 6, 3 and 4. Which is the set already given to you. Do you remember that in a set, changing the order of the elements does not matter. And therefore, this set given in the question and this set that we have obtained by the first option is correct. But this means that my X, if taken to be 1, 2, 5, 6, is giving me the correct answer. But is this X the smallest sized X? For that, we'll have to check some more options. If I go for the second option, it is saying smallest set X is 1, 2, 3, 5, 6. Suppose I take my X to be 1, 2, 3, 5, 6. Then X union 3, 4 turns out to be 1, 2, 3, 5 and 6 union 3, 4. Collect all the distinct members. 1, 2, 3, 5, 6 all are distinct, but because 3 has already been covered, I am just going to take 4 from the next set. What you obtain is 1, 2, 3, 5, 6 and 4. Well, this also matches with the set which is already given to you. That means even the second option is giving me the correct answer. But among the two x's, which one do you think is the smaller one? The first x has cardinality 4 because it has 4 distinct members. Over here, cardinality of x is 5. Therefore, definitely, if the first option turns out to be the correct one, second can definitely not be correct. It is not the smallest one because smaller than that, x is sitting. Right now, let's just verify if there is any other x smaller than the x given in the first option. If I go by the third option, it is saying x has to be 1, 2, 3 and 4. Suppose you take the union of this set with 3 and 4. What is it that I were going to obtain? Let us look at the third option. Suppose x is 1, 2, 3 and 4 and I am taking my x to be the union with the set 3, 4. Then I obtain 1, 2, 3, 4 union 3, 4. I have to collect the distinct members. So 1, 2, 3, 4, that's it because this 3 and this 4 they are already being taken. This gives me the set 1, 2, 3 and 4 which is absolutely wrong because I want 1, 2, 3, 4, 5, 6 which is not the case. Therefore, third option is also definitely not correct. Let's go to the greatest set which is this again. Well, for it to be greatest set or the smallest set, first it has to satisfy this particular condition that on being united with 3, 4, it should give me this set. But we have already verified in option number C that 1, 2, 3, 4 when taken union with 3, 4 is definitely not going to give me right hand side set because 5 and 6 members won't be able to obtain. And therefore, D is also wrong. The correct option is A. This is how we land up in finding the smallest set x which is going to make this relation true. Note this down with a thorough understanding and be braced up to move to the next question. The next question says what I am going to tell you once you already have a look at it and try to come up at least with some tricks and techniques in which you can tackle this question. Question number 4 is demanding your attention in a great deal. It says that in a certain town, 30% of the families own a scooter and 40% own a car. 50% own neither a scooter nor a car. 2000 families own both scooter and car. And then 3 conditions are given to us that 20% families own both scooter and car, 35% families own either a scooter or a car, and actually 10,000 families live in the town. And from this we have to verify which of the options among these 3 is the correct one. 2 and 3 is correct, 1, 2, 3 is correct, 1, 2 or 1, 3 is correct. That means by solving this question we basically have to verify these 3 conditions. Whichever 3 conditions out of them, whichever 2 or 3 come out to be true, accordingly we are going to mark our options right down here. Now as you can see, I don't know how many total families live in the town. Out of that only I will have to consider the percentage of families owning a scooter or owning a car. So let me start with the solution. Suppose the total number of families in the town is X. Let the number of families in the town is X. Then we are given 2 categories in which families are divided. First category is those families who have a scooter. Second category is those families who have a car. 30% families have scooter. So if I say that A is the set of all families having a scooter, in that case, what is the number of families sitting basically like this? How many families have a scooter? They own a scooter. Number of such families is 30% of the total families. Total families we have is X, and therefore this is 30% of X, which is 30 into X upon 100. The next is set B, which is the set of families who own a car. Do we know the number of such families? Number of such families is also given in the question to be 40%. 40% of the total families own a car, and therefore 40 into X upon 100 is the number of families having a car or number of members sitting inside set B. Then it is saying 50% own neither a scooter nor a car, which means 50% families out of the total families are not in set A also, not in set B also. That means they are in A complement and in B complement. Therefore, number of members in A complement intersection B complement is actually the number of families who are not in set A and not in set B, which means they don't have a scooter and they don't have a car also. Therefore, number of members here, this expression is same as, by the very De Morgan's law, A union B whole complement. Once you know the number of members in A union B whole complement, which is 50%, therefore 50x upon 100 is this number. Now what is it that we are supposed to do? Suppose I present before you a small diagram, which is this Venn diagram. Suppose you know that outside A union B, which means over here, in this yellow shaded portion that is outside A union B, which means in A union B complement, these many members are sitting. You also know the number of members in the entire universal set. How can you obtain the number of members sitting inside A union B? The entire or the exact way is just subtract from the number of elements sitting in the universal set the number of members sitting outside A union B, and we will obtain the number of members sitting in set A union B. Therefore, number of members in the set A union B is number of members in the universal set minus number of members in A union B complement. All of us know that universal set, which is the total number of families considered, are taken to be X, and number of members in A union B complement is 50x upon 100. Therefore, X minus 50x upon 100, which makes it nothing but again 50x upon 100. Thus, number of members in A union B is 50x upon 100. We are interested in the fact that how many families own both a scooter and a car. Here we are talking about the intersection of the two sets, because we want those families who have scooter also and car also. Also, by this very fact, if somehow we find what the value of x is, we are going to get the number of families in the town, and we can verify that with the third point. So our aim right now is to find the intersection. What do you think will that be? We know that number of members in A union B is number of members in A plus number of members in B minus number of members in A intersection B. Union, I know how many members are there in the union, 50x upon 100. Number of members in A is 30x upon 100. Number of members in the set B is 40x upon 100. And this is the quantity that we do not know. So in order to know this, what do we do? Number of members in A intersection B is 40 plus 30, which is 70x upon 100, minus 50x upon 100, which is 20x upon 100, which is nothing but 20% of x. But what was x? X is the total number of families, and therefore number of members in A intersection B is coming out to be 20% of the total number of families. Well, that matches with the point number 1, and therefore definitely 1 is correct option. Now the question further is saying 2000 families own both a scooter and a car. We already have number of members in A intersection B to be 20x upon 100, and the question gives me the exact number of this also, which is 2000. 2000 is number of members in A intersection B, which is 20x upon 100. From this, you get x is equal to 10,000. But what was x? X was equal to the total number of families, and therefore total number of families who live in the town has come out to be 10,000. 35% families own either a scooter or a car, which means A union B should be 35% of x. That is not something that we are getting, and therefore second situation is not true. Just look at the options which says 1 and 3 is correct. This does not say that. This says 2 is also correct. 2 is not correct. This says 3 is not correct, but it is correct. 1 and 3, the D option is the perfect option because it says 1 is correct and 3 is correct. This is how you deal with questions like these. Quickly understanding this, note this down in your notebooks and be prepared for the next one. And now we proceed with a new question. I have presented that question before you. Kindly take a look at it. This question is giving us two distinct sets, and we have to discuss about the relationship between these two sets. I have already told you that when you have to establish relationship between two sets, you have to basically discuss how the members of both the sets are interacting. Therefore, set A is given to you to be all those thetas such that tan theta plus sec theta is root 2 sec theta. And B is given to be all those theta such that sec theta minus tan theta is root 2 tan theta. Let me start with set A and decode what actually set A is. I am given my set A to be equal to all those thetas, all those angles, all those arguments such that tan theta plus sec theta is root 2 sec theta. have a particular theta belonging to set A. If theta is belonging to set A, this means tan of this theta plus sec of this theta is root 2 sec theta. We all can convert tan and sec into sine and cos expressions. You know that this implies sine theta upon cos theta plus sec theta is nothing but the reverse of cos theta. So this becomes 1 upon cos theta. This is equal to root 2 into 1 upon cos theta. Once you have obtained this, find out the LCM on the left hand side. What you obtain is 1 plus sine theta upon cos theta is root 2 upon cos theta. The cos theta gets cancelled from both ends and you are left with 1 plus sine theta is equal to root 2 minus 1. This means all those theta who belong to A actually satisfy this, but this expression is nothing but this. This I will remove. All those thetas will satisfy that sine of them will be root 2 minus 1. And therefore, I can write my A to be all those thetas such that sine theta is root 2 minus 1. We have deduced a simpler form of A. That is what we are supposed to do with B also, if that's possible. Let's see what B is. All those thetas such that sec theta minus tan theta is root 2 tan theta. Let's try and decode that. I have set B to be all those thetas such that sec theta minus tan theta is equal to root 2 tan theta. Again, if a theta belongs to the set B, this implies sec of this theta minus tan of this particular theta is equal to root 2 times tan theta. Again, convert this into sine and cos expressions. You will get 1 upon cos theta minus sine upon cos theta is equal to root 2 times sine theta upon cos theta. Now is the turn to find out the LCM on the left hand side, and you will obtain 1 minus sine theta upon cos theta is root 2 sine theta upon cos theta. Cos theta gets cancelled from both ends and you are left with 1 minus sine theta is root 2 sine theta. Now take sine that side so that you have like expressions, and this implies 1 is equal to root 2 plus 1 sine theta. I've just taken out sine theta common and this is what I'm left with. Now I can do one thing. Sine theta is 1 upon root 2 plus 1. I can write it like this. I can just take root 2 plus 1 in the denominator. And now I have to rationalize, which means just multiply by root 2 minus 1 in the numerator and the denominator. What is it that you will get? This will imply sine theta is equal to root 2 minus 1 upon a plus b into a minus b is a square minus b square, which means root 2 square minus 1 square, which is nothing but root 2 minus 1 upon root 2 square is 2. 1 square is 1. 2 minus 1 is again 1, which is you get root 2 minus 1. And therefore set B is again all those thetas such that sine theta is root 2 minus 1. What was my set A? Set A was all those thetas such that sine theta is root 2 minus 1. Set B is also all those thetas such that sine theta is root 2 minus 1. This means both my set A and set B are equal sets. So, which is the option which is verifying that? The very first option itself gives me the correct option, and therefore this is how you have to proceed for solving this question. Quickly note this down and be braced up for the next one. I have already presented question number 6 before you. Take a look and be prepared with the solution sets. Question number 6 is giving us two distinct sets A and B. It is also asking us the number of members in A intersection B, provided the number of members in A minus B is 8 plus 2x. Number of members in B minus A is 6x. And what is x? X is the same thing which it is asking, because number of members in A intersection B is x. One more fact is given, superbly important, which is number of members in A is equal to number of members in B. Now, in order to find this number of members in A intersection B, just see what is given to you. You are already given number of members in A minus B and number of members in B minus A. What do you think is the set which needs both A minus B and B minus A for its construction? That thought is going to bring me to the solution of this question. With the help of A minus B and B minus A, if I take their very union, what I obtain is the symmetric difference of the sets A and B. And therefore, number of members in the symmetric difference of A and B is equal to number of members in A minus B plus number of members in B minus A. But we also had another form of this formula when we had derived the formula with the help of number of members in A minus B's formula and number of members in B minus A's formula, which was that number of members in A symmetric difference B is equal to number of members in A plus number of members in B minus twice number of members in A intersection B. Therefore, by this and this, you get that number of members in A minus B plus number of members in B minus A is equal to number of members in A plus number of members in B minus twice number of members in A intersection B. You already know that number of members in A intersection B is x given to you, and also you know that number of members in A and number of members in B are equal. Just have a look. That is what I said is the most important point, and therefore this expression gets reduced to what? Just substitute number of members in A minus B equal to 8 plus 2x. From here I get 8 plus 2x plus number of members in B minus A is 6x. Therefore, just put that value. Number of members in A plus number of members in B can be written as number of members in A plus number of members in A, because both these numbers are the same, and you get twice number of members in A minus 2 times x, because number of members in A intersection B is x. Once you have obtained this, just bring this 2x to the left hand side and you will have 8 plus 8x plus 2x is equal to twice number of elements in A. 8x plus 2x gives you 10x. Just take out 2 common and write 4 plus 5x equal to twice number of members in the set A. so that I can cancel my 2's from both ends, and you get number of members in A is 4 plus 5x. Still, I am not able to get the value of x, which is the number of members sitting inside A intersection B. Because I am given the information about number of members in A minus B and number of members in B minus A to be 8 plus 2x and 6x, this is what I have to use in order to find my x. Therefore, number of members in A minus B, you know what the formula is. It is number of members in A minus number of members in A intersection B. Number of members in A minus B is given to be 8 plus 2x. Number of members in A we have evaluated is 4 plus 5x. And we know number of members in A intersection B is being denoted by x. Now just solve this algebraic expression. This is 8 plus 2x equals to 4 plus 4x. 5x minus x is 4x. Now 8 minus 4 is 4 and 4x minus 2x is 2x, which implies x is 2. And thus, number of members in A intersection B is 2. Let's see if we have 2 in the solution set. Well, 26, that's not the solution. 50, that's not the solution. 24, even that's not the solution, and therefore none of these is the correct option. Not very much is this option correct when you will deal with the paper, but do not ignore this particular point, because many a times this option, none of these, is also correct. Note this down with thorough understanding so that we move on with the next question. The next question is going to give us some information about the tuples. It is already presented before you. Take a look and come up with some kind of a solution at least. We are given that A is a set of tuples. Also B is not given to me, but just A set is a set of tuples. There is a certain format in these tuples are formed. A comma B is sitting inside set A only when the second ordinate B is equal to twice of A minus 5. Only when B is equal to 2 times A minus 5 can A comma B qualify to sit inside set A. If M comma 5 and 6 comma N are the members of the set A, then M and N are respectively what? So, I am given my set A to be A comma B such that my B is equal to 2A minus 5. I am also given that M comma 5 is a member of this set. If M comma 5 belongs to the set A, but in the set A elements like A comma B belong such that B is equal to 2A minus 5. So this implies M comma 5 is equal to A comma B such that B is equal to 2A minus 5. For some A comma B, I don't know, this tuple is going to be equal to some A comma B for which B is 2A minus 5 because M comma 5 is a member of capital A. Two tuples are equal only when the first entry is equal to the first entry and second entry is equal to the second entry. So this implies that my M is equal to A and 5 is equal to B. But B is equal to 2A minus 5. And therefore, 5 is equal to 2A minus 5, which implies 10 is equal to 2a, which implies that a is equal to 5. But my a is equal to m, and so I get my m is equal to 5. Let's go back to the second tuple, 6, n. Doing the same thing with 6, n, what is it that we proceed by? 6, n is again belonging in the set A. This means that 6, n is equal to a, b for some a, b such that b is equal to 2a minus 5. Again, this would imply 6 is equal to a and n is equal to b. But b is equal to 2a minus 5. And this implies n is equal to 2a minus 5. What is my a? My a is 6. Just substitute it. You get 2 into 6 minus 5, which is 12 minus 5, by which you get your n to be equal to 7. You have got n to be 7 and you have got m to be 5. Let's see 5, 7 is a solution or not. 5, 7 is very much a solution right sitting at the first point. This is how you deal when you have to consider members sitting inside the set and then finding out the values which are asked. Quickly note this down and be prepared for the next question. After dealing with this question, we have a certain bunch of questions still left. Quickly look at question number 8 and try to understand what it is trying to say. Question number 8 is giving us 2 columns. In the first column, there are 3 options, 1, 2 and 3. In the second column, we have A, B and C. I have to match the column. The game which we used to play right when we were young. And therefore, 1 is getting matched to which? 2 is getting matched to what? 3 is getting matched to what is what I have to do, and accordingly answer these 4 queries. Let's try and do 1, 2, 3, A, B, C and see but what is getting matched with what. First of all, what is my 1? 1 is the set L, A and T. That's it. I cannot do anything with it. Let me try and see what is 2. 2 is all those x belonging to the collection of integers, which is z, such that x cube minus x is 0. So, if x belongs to this set, which is given in the second part, then x cube minus x is going to be 0. This means x, if I take out common, x square minus 1 is going to be 0. This means x is going to be 0 or x is going to be plus minus 1, because only then will x square be equal to 1 and you will get a 0. This implies in this particular set given in the second point, my set is actually all the roots of x cube minus x, the integral roots, which are coming out to be 0, 1 and minus 1. So my set 2 has dissolved from any set to this particular set, which contains 0, 1 and minus 1. Let's see what the third set has for us. It is saying that this is a set of these 5 integers. So set number 3 is minus 2, minus 1, 0, 1 and 2. I have obtained in a very elaborate form all 1, 2 and 3 sets. Let us try now and open up A, B and C. A is saying all those x belonging to integers such that their square is less than 5. That means their square can come out to be anything but a number strictly less than 5. If you start with 0, 0 square is 0, which is strictly less than 5. 1 square is 1, strictly less than 5. 2 square is 4, strictly less than 5. And the moment you get to 3, 3 square is 9. That has exceeded 5. Similarly, if I take minus 1, minus 1 square is again 1, which is strictly less than 5, and minus 1 belongs to integers also. If I take minus 2 square is 4, which is again strictly less than 5. Minus 3 square is again 9, which is exceeding 5. Therefore, only 0, 1, 2, minus 1 and minus 2 qualify to be inside set A, and therefore my set A is nothing but 0, 1, 2, minus 1 and minus 2. Let's see what set B is. B is all those x such that x is a letter of the word L-A-T-A, Lata. Basically, if you want to find out the set which this is, you have to collect the distinct members in this word. Distinct members are L, A and T. I am not ticking another A because I have already taken one. And therefore, collection of all the distinct members of the word Lata come out to be L, A and T. Now I am on my journey to see what the set C is. It is sine 0, sine 3 pi by 2, tan 5 pi by 4. So, in order to get this matched somewhere in column A, I want not these values but some integral values at least. You all know what is sine 0. Sine 0 is 0. What is sine 3 pi by 2? Sine 3 pi by 2 can be written as sine of pi plus pi by 2. And sine of 180 plus theta is minus sine theta. You know sine 90 degrees is 1, and therefore minus 1 is what is sine 3 pi by 2. If I tell you what is tan 5 pi by 4, you all know sine 5 pi by 4 upon cos 5 pi by 4 will give me tan 5 pi by 4. Therefore, to evaluate this, let us evaluate sine 5 pi by 4 and cos 5 pi by 4. Sine 5 pi by 4 can be written as sine of pi plus pi by 4. You all know that sine of 180 plus theta is again minus sine theta, and therefore you get this to be equal to minus sine pi by 4, which is nothing but minus 1 by root 2. Again, what is cos 5 pi by 4? I can decompose it as cos of pi plus pi by 4. Again, this is equal to minus of cos pi by 4, which is again minus 1 by root 2. Therefore, tan 5 pi by 4 comes out to be sine 5 pi by 4 upon cos 5 pi by 4, which is minus 1 by root 2 upon minus 1 by root 2, which is nothing but 1. And therefore, sine 0, sine 3 pi by 2 and tan 5 pi by 4, these values when kept in the set C turn out to be this. And therefore, we are in a position to match now. After obtaining A, B and C, let's see from 1, 2 and 3 which is getting matched to what. Set number 1 has LAT and B has LAT, and therefore 1 gets matched to B. Let's see wherein 1 is getting matched to B. Option number A takes 1 to A. It is just wrong. Option number B takes 1 to B. Option number C also takes 1 to B. Option number D takes 1 to A. Again, it's wrong. No need to check further. Let's go and do some more matching. Option number 2 is actually 0, 1, 2, the second set, set number 2. 0, 1, 2 is the set C on the right hand side, and therefore 2 gets matched to C. 2 gets matched to C. Among B and C, who is taking 2 to C? The third option is taking 2 to C, and therefore B is also wrong and C is correct. If you want to verify completely, third will be getting matched to A, because the third set is this and first set is also this. This is how the matching happens here, and accordingly we have been able to mark the correct option. Note this down and be prepared for the next question. Now we come up to our second last question. This is pretty interesting. Just take a look. I am sure everybody would be able to decode that. This question says that A is a set wherein the format of numbers who sit inside A look like this: n cube, n plus 1 cube, n plus 2 cube, where this n is belonging to the set of natural numbers. Now, B is also a set given to be 9n, where n belongs to the set of natural numbers. This means if I try and open my set B, my set B comes out to be 9 into 1, which is the first natural number. 9 into 1 gives me 9. 9 into 2, which is the second natural number, gives me 18. 9 into 3 gives me 27. And if I proceed like this, what is this? Is basically the table of 9. All the multiples of 9 are given here in set B. We don't know what set A is. We just know the format of the members in set A, which is n cube plus n plus 1 cube plus n plus 2 cube, where my n is coming from the set of naturals. In order to understand what are the elements sitting inside set A, let us try and put the value of natural numbers one by one. If I take my n equal to 1, I get 1 cube plus 1 plus 1, which is 2 cube, plus 1 plus 2, which is 3 cube. What is this? 1 plus 2 cube is 8 and 3 cube is 27. So you get 1 plus 8 plus 27, which is 36. Next, if I put my n equal to 2, what I get is 2 cube plus 3 cube plus 4 cube, which is 8 plus 27 plus 64, which is going to give me 99. If I start with n equal to 3, I am going to get 3 cube plus 3 plus 1 is 4 cube plus 3 plus 2 is 5 cube, which is 27 plus 64 plus 125. Which is going to give me 216. If you keep on proceeding like this, there is a pattern. What is the pattern? Just relate 36, 99 and 216 with the table of 9, because that is what we have in picture right now. 36 can be written as 9 into 4. 99 can be written as 9 into 11. In fact, 216 can be written as 9 into 24. This is the pattern which gets followed. This means inside set A, we don't have every multiple of 9, but whichever members are there are definitely multiples of 9. Therefore, every member of A is already a member of B, because B contains all multiples of 9. Thus, the conclusion is that if X is a member which belongs to A, it will be a multiple of 9 and therefore it is going to sit inside B also. And thus, my A will be a subset of B. This is the relationship between the sets A and B. Let's see which option gives us that leverage. The first option is what is the correct one, that my A is a subset of B. In fact, it is true that it's a proper subset because A does not contain all the multiples of 9. Therefore, B, C and D are wrong options. Understand this and then we will move to the last question. Now we are prepared to meet the last question of this particular category. Quickly take a look at it and try to solve it. Question number 10 is giving us two sets A and B with 3 elements and 6 elements respectively. A is a set having 3 elements, B is a set having 6 elements. What can be the minimum number of elements in A union B, and also find the maximum number of elements in A union B? The tuples that are given basically are, the first element tells you the minimum number of members in A union B, and the next tuple, the next element in the tuple tells you the maximum number of members in A union B. So all in all, we have to deal with A union B. Therefore, let us write the formula for the number of members in A union B. We know that number of members in A union B is equal to what? It is number of members in the set A plus number of members in the set B minus number of members in A intersection B. If you try and observe this carefully, if I observe number of members in A intersection B is getting subtracted, which means if number of members in A intersection B is minimum, then minimum quantity will be subtracted from this expression. And therefore, maximum number of members in A union B will be obtained. In order to obtain the maximum number of members in A union B, number of members in A intersection B should be minimum. So, if I take my case 1, that number of members in A intersection B is minimum. What is the minimum number that A intersection B can have? That means A intersection B is the number of members common in A and B. What can happen? The worst case scenario is when A and B have nothing in common, which means number of members in A intersection B is 0. That is my minimum case. This means this can happen when A intersection B is an empty set. That means there are no members which are common to A and B. Once you have this, my number of members in A union B will be maximum because I am reducing nothing. Therefore, this is equal to number of members in A plus number of members in B minus 0. Number of members in A is given to be 3 and number of members in B is given to be 6. Therefore, 3 plus 6, which is 9, is the maximum number of members in A union B is your 9. Now is the turn to calculate, after dealing with this case, the minimum number of members in A union B. If I subtract the maximum possibility of number of members in A intersection B, I am going to get my minimum number of A union B. What is the maximum number of A intersection B? Well, A contains 3 members, B contains 6 members. Maximum to maximum, this can happen that all the 3 members of A are contained in B, in which case the intersection of A and B comes out to be A itself. Because what will be the scenario then? In that case, this will be my B and this will be my A. All the 3 members of A will come inside B only. In that case, A intersection B will turn out to be A. And therefore, in this particular case, my number of A intersection B will be maximum, which is 3. So I come to case 2, when number of members in A intersection B is maximum. What do I mean by that? This means number of members in A intersection B is equal to number of members in the set A, because here A intersection B will come out to be equal to set A. And I know the number of members in set A, which is 3. Therefore, the minimum number of members in A union B will be number of members in A plus number of members in B minus number of members in A intersection B. Number of members in A is already given to be 3. Number of members in B is already given to be 6. And number of members in A intersection B is same as number of members in A, which is again 3. And therefore, 6 plus 3, 9, 9 minus 3, which is 6. Therefore, minimum number of members in A union B is 6. 6 is the minimum number and 9 is the maximum number. 6, 9 is the tuple that I am going to search over here, or maybe 9, 6, whichever suits me. The question is saying finding the number of members maximum and minimum. 9, 6 is given to be the first tuple. Rest all the tuples basically give me the wrong answer. Therefore, 9, 6 is the correct option, and this is the solution of the question, 10th number. This is how you have to deal with it, understand it, imagine the situation and proceed with it. This is where I end my today's JEE Advanced pattern questions. Practice them nicely so that this benefits you in your preparation. Goodbye.